Okay, equations and complex solutions. This is Unit 2, Day 2. Make sure you have your notes out. So, some vocabulary, like every video. So, every quadratic equation has a complex number solution that sometimes are real numbers, are just complex number solutions. Equality property for complex numbers. If two complex numbers are equal, then the real parts are equal and the pure imaginary parts are equal. So say you have a plus bi and c plus di, then a equals c and b equals d. Okay? So product property of complex numbers is the product of a non-zero complex numbers and its conjugate is a positive real number. So that's a minus bi times a, or a plus bi times a minus bi equals a squared plus b squared, which ends up just being a real positive number. Okay, that last definition, just ignore it. Okay, the fundamental theorem of algebra is every polynomial with complex coefficients and of degree n, where n is greater than 1, can be factored into n, so whatever the degree is, linear factors, and blah, blah, blah. Okay, I'll get more into that in later lessons, okay? The reciprocal of a complex number, z, and 1 over z, where z cannot equal 0. So that's the multiplicative inverse of a complex number. And then sum and product of roots for a squared, or ax squared plus bx plus c. So the sum of the roots is negative b over a, and the product of the roots is c over a. I'll get more into that later in this video also. Just make sure you have it written down, okay? So finding pure imaginary solutions using the square root method. This is the easiest method. So if you have some x squared plus something, you can just use the square root. So first, I'm going to subtract the 20 over. So you end up with 5x squared equals negative 20. Divide by 5. You get x squared equals negative 4. Square root both sides. And so the square root of negative 4 is plus or minus 2i. Okay? We're going to do the same thing for b. Subtract the 15 over, square root both sides. You can't take the square root of 15, so that's plus or minus I square root of 15. Okay, pretty straightforward for those ones. Now let's go to these ones. So we have to solve these. So first, remember that equality property where we had ax plus bi equals cx plus di, where a equals c and b equals d? That's what we're going to use for this first one. Okay, so 3x equals negative 18. So I'm just going to set those two equal to each other. And 5yi equals 20i. Set those two equal to each other. We're going to solve the first one for x by dividing by 3. And you get x equals negative 6. And then we have to solve for y on this second one. So you're going to divide both sides by 5i. You're left with y on the left side. 20i divided by 5i, the i's cancel and you're just left with 4. Okay, pretty straightforward for those ones. So now we're going to go to example C, and I'm going to make this a little bit bigger. So this one's more complicated. So we only have one variable x. So we have to get all our x's to one side and everything else to the other side. Okay, so I'm going to add the 1 minus ix to both sides. So I'm going to move it from the right side to the left side. Okay, so I have 3 minus 5i plus 2ix plus 1 minus ix equals 3i. And then I'm going to subtract 3 and add 5i to both sides so I can move that over to the right side. Okay, you could have moved it all your x's to the right side and all your i's or everything else to the left side. I just decided to move mine to the right. Okay, so I end up with 2ix plus parentheses 1 minus ix equals 3i minus 3 plus 5i. You combine those i's on the left or on the right and you get 8i minus 3. Okay, now if we look at the left side of this equation, we can take an x out of both of those. So I'm going to factor that x out and I'm left with 2i plus I minus I, or plus 1 minus I equals 8i minus 3. Combine your i's in there, so x times that, and then to get the x by itself, we're just going to divide both sides by I plus 1. Okay, so we get x equals 8i minus 3 over I plus 1. And then we have to get this so we don't have I in the denominator, because mathematicians don't like I in the denominator. Multiply by the reciprocal. If we multiply it out, you end up with 8i squared minus 8i minus 3i plus 3 over I squared minus I plus I minus 1. So those i's cancel out. And remember, I squared equals negative 1. So I'm just simplifying this down now. And this just continues to go through those steps, and you end up with 5 plus 11i over 2. Because if we look right here, everything in that is negative. So we can just divide everything by negative, multiply it all by negative, and that's how we end up at this. Right there. Okay? And remember, you can also write that as 5 over 2 plus 11i over 2. I'm good either way. All right, so finding imaginary solutions. So we're gonna watch this fun little YouTube video. See if you guys remember quadratic formula.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you try. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, obviously that's just a silly way to remember it, but it's a pretty easy way to remember it also. Ah! Stop. What's happening? Sorry. Okay, we're back. All right, so the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we look at example A equals 3, B equals negative 1, C equals 2. So I'm just going to write those down, and then you just plug those straight into that quadratic formula. Okay, and then you just go through and you simplify it. So it's 1 plus or minus the square root of 1, because negative 1 squared is 1, minus 4 times 3 times 2 over 6. Continue to simplify that down. And you end up with 1 plus or minus the square root of negative 23 over 6, which is 1 plus or minus I square roots of 23 over 6. And that's your answer. Okay, and remember, this is 2 answers. I don't think I wrote this as 2 answers, but I just want to show you. So this is x equals 1 plus I square roots of 23 over 6. This is also x equals 1 minus I square roots of 23 over 6. So there are 2 answers there. That plus or minus means there's 2 answers. Okay? Okay, so we have to find the reciprocal, then use complex conjugates to simplify. So we're going to save that one for class. Find the sum and product of the roots. So first let's find the roots. This can't be factored, so we have to use the quadratic formula. So we're just going to plug all that in. A equals 1, B equals negative 3, C equals 4. So that's x equals negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 4 all over 2 times 1, which simplifies to 3 plus or minus the square root of 9 minus 16 over 2, which is 3 plus or minus the square root of 7, negative 7 over 2. So that's 3 plus or minus I squared to 7 over 2. And again, that is 2 answers right there. Okay? So if we're going to find the sum and the product of these. Sum is addition, product is multiplication. So if we're going to do sum, we're going to add 3 plus I squared to 7 over 2 plus 3 minus I squared to 7 over 2. They have the same base, so I can just add across the top. 3 plus 3 is 6. I squared to 7 minus I squared to 7 is nothing, so it goes away. So it's 6 over 2. That reduces to 3. Okay? If we find the product, you can just multiply this top using either the box or you can use distribution. And you end up with 9 minus 3I squared to 7 plus 3I squared to 7 minus I squared times 7. Because I squared to 7 times I, negative I squared to 7. That's I times I, which is I squared. Square root of 7 times square root of 7 is 7. And then those 3I squared to 7 cancel. I squared is negative 1. So that becomes 9 minus negative 7, which is 9, plus 7, which is 16. 16 over 4 is 4. Okay, and if you remember the sum of the roots and the product of the roots, so the sum is negative b over a. Whoops, go back. So negative b, so b is negative 3, negative b is positive 3 over 1 is 3, which is what we got right here. Okay, c over a, so c is 4, a is 1, which is the same thing as 4. Okay. Writing or find a quadratic equation for the pair of roots, and we're going to assume a is 1. So we're going to use the sum of roots and the product of roots. So we know the roots. So let's find the sum of the roots. So we're going to add them together. That equals b over a. Well, negative 5i plus 5i is, oh wait, sorry. We're assuming a is 1, so I'm just going to plug 1 in for there. So then that just becomes negative 5i plus 5i equals negative b. Negative 5i plus 5i is 0, so 0 equals negative b, which means b equals 0. Okay? Then we're going to do the product of the roots. So the product of the roots equals c over a. We're going to assume a is 1, so I'm just going to plug 1 in for that. So that just equals c. That becomes negative 25i squared equals c. Negative 25 times negative 1, because I squared is negative 1, equals c. So c equals 25. So if we write the equation for this, a is 1, so it's 1x squared plus 0x plus 25, which is the same thing as x squared plus 25. Okay, let's do this last example. So let's do the sum of roots first. So we have 2 plus I plus 2 minus I equals negative b over a. A equals 1, so it just equals negative b. The i's will cancel because 2 plus 2 is 4. I minus I is 0, so it's 4 equals negative b, which means b equals negative 4. Okay, now we're going to do the product. So the product equals c over a. A equals 1, so that just equals c. You can multiply that out using distribution, and then those two i's cancel. I squared is negative 1, so that becomes 4 minus negative 1, which is 5. So c equals 5, b equals negative 4. And if you write this equation, that's 1x squared minus 4x plus 5, which is the same thing as x squared minus 4x plus 5. Okay? Remember to take the quiz, and I will see you guys tomorrow. I'm also going to post that quadratic formula video on Facebook, so you can put it as your ringback tone or whatever, or ringtone. I guess ringbacks aren't a thing. But so you can listen to that and try and remember it.